Bismillahirrahmanirrahim. In this video tutorial of 3ds Max, we will be using a basic polygon editing to create a helmet. So when you model a rounded object such as the helmet in this tutorial, we recommended that you avoid using a sphere as a starting point. The next illustration shows the polygons that make up a sphere. The top of the sphere is composed of triangular polygons whose vertices tend the pin together at the pole. This can lead to problems later on. It is therefore best to model a rounded object other than an actual sphere using rectangular polygons only. You will use this technique in this lesson. So start your 3ds Max. By default, a minimized version of the graphite modeling tool ribbon displays directly below the main toolbar. Something like that. As you can see, the ribbon has been situated here. So click the expand or minimize icon a few times until the full ribbon displays. Just go to this little icon and click this once or sometimes a couple of times to display the full modeling ribbon, as you can see there. Let's change the place of this graphite tool. Just hold this head of the graphite tool and drag him down and drag him up. So we had changed the place of this graphite modeling ribbon. The tools in the polygon modeling tab are inactive since no polygon model exists in this scene. From the customize menu, choose unit setup. Go to customize menu, choose unit setup, and the unit setup dialog display unit scale group. Make sure the genetic units is on. Just click on that and click OK. Now after that, just activate the perspective viewport and then click the shading viewport label and choose edge faces. After this choice, the shading viewport label should show smooth plus highlight plus edge faces. Now go to the create panel and in the object type rollout, click box. Drag to create a box of any size. On the modify panel and in the parameters rollout, set the length, width and height to 50. Just type 50 in length, 15 height, width and also 50 in height. Currently, the pivot point is at the base of the object. You need to set this point to the center of the box so you can manipulate the object more easily. In the hierarchy panel, go to the hierarchy, adjust the pivot rollout, and in move, rotate and scale group, click effect pivot only to turn it on. Just click on effect pivot only. In the alignment group, click center to object. Then click effect pivot only again to turn it off. On the main toolbar, click rotate and rotate the box. Just rotate him slightly. The box now rotates around the object's center of mass. Okay, let's undo our rotation. Let's come out from hierarchy, being in the modify panel. Now just right click of the box And in the transform, just click on the move. Right click the X, Y and Z transform spinners to set each of them to 0. So simply just to right click on these little arrows. In the X axis 0, click on a Y and also click on a Z. The center of the box is now at the center of the world's coordinates. On the Modify panel, Parameters Rollout, set the length edges, width edges and height edges to 4. All of us just select the length edges, type 4 and hit enter. And the width edges 4 and hit the height edges, also type 4 and hit enter. Now from the modify list, in a drop down, click on this little arrow and in the drop down list just choose Spherify. Just look for the Spherify option and here is that, and apply this on our box. So as you can see, our object should looks like something like that. It's looking something like a sphere. The object is deformed into a spherical shape, but retains its geometric compositions of easily editable quadrilateral polygons. You only need a hemisphere to create the helmet. So next you will delete the lower half of the box and deform the remaining polygons into a conical shape. At that point, I will suggest you to save your project with the name of your choice. Now we will refine the shape. In the viewport, right-click the sphere and choose Convert to Editable Poly. Right-click, Convert to, and then Convert to Editable Polys. Now one thing you must notice that the ribbon updates to display a range of polygons editing tools. Now orbit the viewport until the vertices on the lower half of the box clearly visible. Just like that. As you can see, the all vertices of down are now a little bit visible. Okay. Now on the ribbon and in the polygon modeling panel, active the vertices as I had done, vertices selection mode, and then region selected all the vertices in the lower half of the object. So I think the front viewport will be the best to do that. Just go into the front viewport and select all the down vertices with the region selection and hit delete. Now go to the perspective viewport and you now have a hemisphere room for the helmet. Next you will give the object a slightly conical shape. Now select the vertex at the very top of the helmet. I think this one will be the good. Just select it and drag upward on the z-axis. Just drag him. Not so much, just bring him down a little bit, and okay, I think that's good. Notice that only the polygon that share the vertex are deformed. You need to use soft selection to involve the adjacent vertices and polygons as well. Now simply just undo the vertex move a couple of times. On the ribbon polygon modeling panel, click soft selection to turn it on. Here is the soft selection button. Just click on that to make the soft selection on. Now on the soft selection drop down panel, set the fall off to 30. Just go here to the soft selection and in the drop down panel just type fall off to 30 and hit enter. Okay, now drag the top vertex of the helmet on its z-axis again. Okay, drag it until the object appears similar to the next illustration. Okay, I think it's good. Okay, it's good now. Now on the ribbon and in the polygon modeling panel, just click soft selection again to exit the soft selection mode. Next, you will use the mesh smooth tools to smooth out the helmet surface. In the viewport, drag to select all the object's vertices, or simply press Ctrl A, Ctrl plus A to select all the vertices. Now in the ribbon, just go to the subdivision panel, which is just situated here, and click on mesh smooth. This option takes each polygon and divides it into 4, making a smoother, more detailed geometry. On the ribbon, just go to the polygon modeling panel and then click on vertex to exit this selection mode. Now at that point, just save your scene with the name of whatever you want to give it. Okay, now you will work in symmetry mode on half the helmet. This way, any change you make will be perfectly mirrored for the other half. Okay, on the polygon modeling panel, active the polygon selection mode. Just click on polygon and activate. Now go to the ribbon selection tab and on the by half panel, click Y, then click the selection button. Just click on this by half and click on Y and then click on selection button, and there we have it. As you can see, this selects half the object base on its y-axis orientation. Now just go back to by half once again and click on invert axis. The polygon selection is inverted. These are the polygons you want to remove, and press delete. You will now add a symmetry modifier to these polygons so that their geometry can be mirrored. On the ribbon, click the Graphite Modeling Tools tab, and with the helmet object still selected, go to the Modify panel and from the modifier list choose Symmetry. Just click on the polygon modeling and there is Symmetry Tools. Just click on that and a Symmetry Tools dialog box will be appear. Or you can do the same work. Just close that for now. You can do that by going on the modifier list and choose Symmetry option from there. Just click on Symmetry and apply this to our object. On the parameters rollout, mirror axis group, choose the Y option and turn on flip. Just choose the Y option and turn on flip. This properly orients the mirrored half of the helmet. Notice how the ribbon displays a limit set of the modeling tools. This is because the symmetry modifier is active. You can see these little arrows, previous modifiers. On the ribbon polygon modeling panel, click the previous modifier button. The editable polymorpher is now active, and the ribbon displays an expanded set of tools for polygon editing. The mirrored half of the helmet is hidden in the viewport because with polygons editing controls displayed, you are editing the source polygons only. On the polygon modeling panel, just click this show and result to see mirror side of the helmet controlled by the symmetry modifier. Click show and result again to exit this mode. Now to preview the mesh smoothing, go on the edit panel and then click on the use norms tool. Just click on use norms tool. Okay, click on that and the use norms panel displays at the right of the ribbon. Norm is sorted for non-uniform rational mesh smooth. On the use norms panel, set iteration to 2, type 2 and hit enter. This smooths out the object by adding more polygons to the geometry. It is best to specify an iteration value of no more than 3 because each time increase iteration by 1, the number of vertices and polygon faces can increase by a factor of 4. This can result in a lengthy calculation time. If the showcase button is already on, turn it off to better see the geometry added by the norms iteration. Okay, just click on that and you can see how the effects are being now. Next you will add 2 extrusions that will form the rim of the helmet and its vertical seam. On the ribbon and in the edit panel, just click the use norms to turn it off. Just click on the edit and click on norms to turn it off. Okay, it's off now. On the polygon modeling panel, active the edge selection mode. Just click on this and click on edge selection mode to turn it on. Okay, in the viewport, select a polygon edge and then click any of them and then click on the modify selection panel, click the ring. Or you can do that by simply click here in the selection rollout, click on the ring. All edges parallel to the first one in a ring around the object are selected. Now on the loops panel, press the shift and click on connect. Just press your shift and click on connect. A single loop is drawn around the selected edges. By default, the loop is placed in the center of the selected edges, but the negative slide value you will specify in the next step will position it to the left of center. On the connect edges dialog, set slide to -50 and then click OK. Just in the slide, type minus and 50, then click OK. Okay, now in the viewport, click a vertical edge on any polygon at the bottom row of the helmet and on the ribbon in the modify panel, just click on the ring tool. The ring tool automatically selects all the vertical edges. On the loops panel, just hold down the shift key and click on the connect. Just click on the connect. On the Connect Edges dialog, set the slide to -25.0. Just set it to -25.0 and click OK. On the polygon modeling panel, click Show and Result to see how the symmetry modifier has added a mirror portion in the helmet. Right click the helmet and choose in the transforms and go to the convert to, then convert it to editable polys. The symmetry modifier is removed and all the mirrored polygons are integrated into the model. Now on the ribbon, in the polygon modeling panel, activate the edge selection mode. Just click on edge selection mode and activate it. Now on the modified selection panel, click on this loop mode and turn it on. Now just zoom in a little bit to the element and click an edge along the center edge of the element. Okay. With loop mode on, 3ds Max selects all center edges. Okay, with loop mode still active, hold down your Control key on your keyboard, then click an edge along the bottom edge of the element. Just pan out a little bit to the upper. Okay, with the Control key and select this one. Hold down the Control and on the ribbon and in the polygon modeling panel, active the polygon selection mode. Just click on this polygon button. As you can see, all polygons connected to the selected edges are now selected. On the polygons panel, hold down Shift and click on the extrude option, which is just click on this extrude. Okay. On the extrude polygons dialog, extrusion type, group and choose local normal. Just click on that local normal. Now set the extrusion height to 1 and click OK. On the ribbon and in the polygon modeling panel, click polygon selection to exit sub-object mode. Okay. On the edit panel, click use norms and on the use norms panel, just click on that. Just go to the click on this show cage button to hide the cage. Okay. Then press F4 on your keyboard to see the end results. There we go. Okay, now we will work on helmet's middle seam and rim extrusions. On the use norms panel, set the iteration to 2. Type 2 and hit enter for the further smooth out of the helmet. In the next few steps, you will add more edges to create a less rounded extrusion to the helmet rim and middle seam. Now once again, I will suggest you to save your work at that point. Okay, with the helmet still selected and make sure the modify panel is active, just to go to the ribbon and in edit panel, click use norms to turn off norms mode. In the viewport, switch to left wireframe view. Just select the left wireframe and maximize it. Just zoom in a little bit to our helmet object. Okay. Now notice the slight wave to the extrude rim of the helmet. On the ribbon, in the polygon modeling panel, active the vertex selection mode. Just click on the vertex button, then region, select the second from bottom two rows of vertices. Okay, just click in the screen to deselect the selected vertices, and with the region selection, just select this line very slightly. Okay. On the align panel, click Z to align all the vertices along their average orientation on the Z axis. Simply just click on this align button, and in the drop down list, click on the Z. Okay. Now just click on this again to close him. Switch to top view and region selected, and with the region selection, select the vertices on one side of the seam extrusion. Just go to your top viewport, maximize your viewport, just zoom in a little bit to the object to see it clearly, and just select all the vertices of this side with the region selection. Okay. Now on the ribbon and in the align panel, just to click the align, and that time click on Y to align all the vertices along their average orientation on the Y axis. Okay. Now with the region selection, select the vertices on the opposite side of the seam extrusion. Okay, with your region selection, just select these one. Just go back once again to your align and click on Y axis as we did to previous. Okay. Now change your viewport to the perspective view once again. Now on the ribbon, in the poly modeling panel, active the edge selection mode. Just click on edge selection button and activate it. Okay, let's hit F4 on your keyboard to see the faces, and just zoom in a little bit to your object. Now click a polygon, lower polygon edge on the modify, then on the modify selection panel. First let me select the edge. Okay. Now on the modify selection panel, click the ring tool. Just click on that. All edges parallel to the one you selected are also selected automatically. Now on the loops panel, just go on the loops panel, and with the hold of your shift on your keyboard, click on connect edges dialog box. Set the slide value to 83.0 and then click OK. Just click on this connect. Okay, and connect edges dialog box will be appeared. So in that, set the value, the slide value, to something like 83.0 and hit OK. Okay, now just rotate the helmet object so that opposite side of the vertical seams is clearly visible. So like this, as you can see. Now on the edit panel, click the swift loop tool. Go in edit panel and click on swift loop tool. Now as you can see, a green virtual loop appears as you drag the mouse over the helmet. It lets you visualize where to place the loop. Click to place the loop. Okay. So it should be equally distant from the extrusion as the loop on the other side of the extruded seam. 3ds Max automatically creates a loop perpendicular to the selection point. This method is a fast way to create and position a loop on a model. Okay, now position your cursor over a polygon edge just above the helmet rim. Now, using the green virtual loop to visualize the loop placement, then click to create the loop. Okay, we had created it. Now as we had created our loops, now go back and click on the Swift loop tool again to deactivate it. On the ribbon tool and in the edit panel, just click use NURBS to activate it. Just click on NURBS once again to activate it. Okay, now press F4 to turn off edge faces and see how the added loops give the extrusion joint a sharper angle. Just click F4 on your keyboard. Okay, now press F4 again and click the use NURBS to turn it off and redisplay the underlying model. Okay, click on NURBS once again. Okay, now at that point I would suggest you to just save your work and your project.